In this video, we're going to talk about the one technique that we're going to use this year to integrate something that would require like product, chain, or quotient if we were differentiating it. So the good news is there's only one technique. The bad news is that it's pretty difficult. But our key thing that we're looking for here is to find a piece of the function whose derivative is also in the function. Again, it's the reverse of that chain rule. So like when we are differentiating, remember we leave it in and then we also multiply by its derivative. So if we can find those two pieces, we're going to make a substitution. Again, we're going to choose a new variable, we call it u, and we're going to look for something that's an inside function or a denominator. We're going to kind of look for that baby. We're going to rewrite the problem in terms of u, so our notation has to be accurate. Typically we have a dx at the end because all of these are x's. If we write it in terms of u, then this has to say du at the very end. It cannot stay dx, so we're going to talk about how to rewrite that. And then kind of the key here is that we don't want any u's in our answer. So if we end up with a u, we do have to plug it back in. If, however, we have a definite integral like numbers at our bounds, we're actually going to get a numeric answer, so there's no reason to plug u back in. So we need to kind of think about that. Okay, so our first step is to identify that u. When we look at this, we should know that we cannot integrate it because this kind of looks like it would be chain rule and product rule, and there are no rules like that for integration. So we want to make a choice for u, and this is kind of trial and error. Now, a good rule of thumb is to look for those inner functions, kind of like maybe what would typically be like a baby. So in this case, we're going to look for this guy. So we're going to start off by saying u equals x squared plus 1. And if we realize that it's not working out, we may have to go back and try the process with something else. But again, we want the inside, so we don't want to include this guy. We only want that inner function. So when we replace u, so we're going to plug a u in here. This cannot say dx anymore. It needs to say du. Remember, du is part of a differential. Du dx is where we've seen this before. And the way we read that is the derivative of u. Well, here's u, so its derivative is 2x. Now, in my problem, I'm looking for something to replace dx. And so we're going to need just du. So since we only need du, we're going to multiply this on the other side. So we see that the value of du equals 2x times dx. And now we're ready to start using substitution. So we have to start by finding u and du so that we can start replacing things in our original integral. So this is going to become the integral of u squared. So all of this comes out, and u goes in its place because they are equivalent. So this becomes u squared. Okay? And then 2x dx can be replaced by du. So all of this is equivalent to du. And now we have a much nicer integral to evaluate. All of my variables are aligned. I only have u's in the problem, and this says u should be the variable in the problem. So now we integrate like usual. So we're going to add 1 to our exponent. We're going to divide by our new coefficient. Our new exponent. And then since this is an indefinite integral, we're going to add plus c. And just remember, we don't want any u's in our answer, so we can't actually leave this as an answer. We do need to go back and replace that with our function from the beginning. And so remember, u is equivalent to x squared plus 1. So all we're going to do is plug that in. Also, remember that we can check our answer by taking the derivative of this function. And we should get the integrand that we started with. So if we differentiate, we should get this as its derivative. Okay, we have another one here. So again, this would require chain rule because cosine is only allowed to be cosine of x. So we want to take care of that by replacing it with a single variable. So we're going to make the choice that u is going to equal 4x. Remember, we're going to have a du at the end because u is going to be the variable in the problem now. So du is the derivative of u. Well, if this is u, its derivative is 4. Don't forget that dx has to be there. Remember, it started down here and we multiplied it over there. And then now we're going to start using the process of substitution. So we can plug u in right here. So this becomes the cosine of u. And so remember, we're replacing variables. So this is a function. He stays. So those are gone. I have a 4 and a dx. And I know that 4 times dx is equivalent to du. So both of those can go out and du can come in. And now we go ahead and integrate. And I know that cosine is the derivative of just sine. And this is an indefinite integral, so it wants every antiderivative. So I need a plus c. And then just remember, we don't want to see a u in our answer. So we're going to go back and plug in that expression for u. And again, if we differentiate this, we should get the integrand of this problem up here. Okay, so here's a little bit more complicated one. Again, we're going to make our choice for u to be our inner function. So our u is going to equal x squared plus 2. Our du then is going to be 2x dx. When we make our substitution, this piece goes out, and I get u to the third. Okay, the problem in this example is that this x times dx I see here, but I have this 2. And so remember, we want to know what x dx is equivalent to. So we can actually isolate it by dividing both sides by 2. So on this side, I get 1/2 times du equals x times dx. So it's a lot of kind of manipulating to get it to look like what we want. We wanted it to just be x dx so that these can swap out and this can come in. So we have 1/2 times du. And just remember, typically coefficients we can bring way out front. That's kind of up to you, or we could even put them right here. In this case, I'll probably just maybe leave it right here. And now we're just going to integrate. So again, we're going to add 1 to our exponent, and then we're going to divide. So if I divide by 4, I get 1/8, and then I have plus c. And then also just remember, we don't want a u in our answer, so we're going to have 1/8 x squared plus 2 all to the 4th power, and then plus c. In this next example, I'm just going to help you choose your u value. Again, we want to choose the inside or a denominator. In this case, I'm just going to choose the inside function of the denominator to be u. And then d would equal 8x. Dx. And then once we're substituting, just remember, we replace u first, so this is going to be u to the 6th. In the numerator, we have an x and a dx. So we're going to have to isolate this piece by dividing by 8 before we go ahead and finish plugging it. Okay? Our last example here, now we have a definite integral. Just remember, everything needs to match. Also remember, these are x values. When this is an x, my beginning and ending limit are x values. So when I want to make a choice for u, I'm going to choose 1 plus x cubed. My du then is going to be 3x squared dx. When I go to make my substitution, this goes out, and it's now going to be the square root of u, or u to the 1/2. Okay, so this is now taken care of. I still need 3x squared times dx, which I have here. It's equivalent to du, so it can go out and du can come in. I have to be very careful now because the problem states that this is in terms of u now. And remember, these were x values. So I need to turn them into u values. So because each of these are equal to x, I can actually plug them into this expression, and then they're u values. So u of 0 says I'm going to plug 0 into this problem, and I get 1. So when x is 0, my equivalent u value is 1. Now I'm going to say u of 1, so I'll have 1 plus 1 cubed, or 2. So when my x value is 2, I'm sorry, this should have been a 2. There we go. So we actually get 9. When x is 2, my equivalent u value is 9. So this is now the integral that I'm evaluating, and there's no reason to ever use x's at all anymore. So I'm going to go ahead and add 1 to my exponent. I'm going to divide, and I'm evaluating from 1 to 9. And remember, these are u values now. So these can go directly in for u because these are both u values. Remember, I can rewrite this as the square root of u all to the third power. So my final answer, I'm going to have 2/3 times the square root of 9 to the third minus the square root of 1 to the third. And we can simplify. We would get 27 minus 1 all times 2/3, and we can simplify that.